Hello, students. Welcome to my home. I'm excited to give you this quick lesson. So I'm not here at school today. In the future, I'm not here because in 2 days I'm going to be moving. So I'm pre-recording this lesson for you so that you can do the classwork. Here you go. So here's your notes for today. Just want to tell you the most important things you need to know about the notes. So the first part is a review. Is that when you talk about velocity, just be aware when you answer the questions, we're not just talking about speed. If we change speed or we change direction, we're changing velocity. That's because velocity is a vector. It has direction and magnitude. This word magnitude you may or may not have thought about before in terms of velocity, but magnitude just means how long it is. What is the absolute value? So just like when we talk about a speed in a car, the speedometer tells us how fast you're going. It doesn't necessarily tell you what direction you're going. It only tells you the speed. It tells you 20 miles per hour, 30 miles per hour, 40 miles per hour. It tells you the magnitude, but not the direction. However, when we talk about velocity, it matters what direction you're going. Up is often considered positive, and down is often considered negative. And that's how we consider them in this class. So the direction matters. So a motion that is going to the right and up at 10 meters per second is different than motion that is going down or to the left. And that will come back later. So just remember, direction does matter if we're talking about velocity. And it becomes even more important in this unit as we talk about two dimensions. So a couple of math things for you is if we're going at some angle, this symbol means we're not going straight up or straight to the right. We're going at some angle theta. Let's say, for example, we're going at 5 meters per second at some angle. If we throw something up at some angle, then it's not going fully up or fully to the right because that's some angle. You can do this for yourselves, and I'll show you this in class when you get back. But if you apply the same force, you throw something straight up, it's going to go straight, it's going to go higher than if you throw it at some angle. And so you can find the exact values by taking the sine and cosine of that angle. To use a common example, if it's at about 37 degrees, if we throw it at 5 meters per second, that's the same as saying that our Vy is 4 meters per second. Even though we threw it and it's going at a total velocity of 5, its upward velocity, which is Vy, is only 4 meters per second. Just a note, whenever we say Vy, we're talking about the vertical or up and down velocity. We also have to consider what's happening in the horizontal velocity. Horizontally, we would be going at 3 meters per second for that example. Now, using a little bit of math in the Pythagorean theorem, we know that a squared equals b squared plus c squared. And so because this is a right triangle, we know that they will have those relations. So going back to that same 37-degree triangle, 5 squared is 25. And on your own, you should be able to see that 4 squared plus 3 squared is also 25. And so that's why we have this special 5, 4, 3 triangle, or the similar triangles that are multiples of that. We'll get more into actually using the sine and cosine later, but I just wanted to show you that if you're going at an angle, you are not going at the full 5 meters per second up or to the right. You're going at a lesser value in both of those directions. Okay, here's the meat of what I want you to know today. Here's a nice picture of what happens when we throw something in the air. This could be a basketball player taking a shot at a basket. This could be a trebuchet launching something. This could be a football player trying to kick a field goal. But whenever we throw something into the air at an angle, we have two things going on at the same time, and both are important. First, we're going to the right. I want you to notice these blue arrows. What's happening as time passes? So let's say this is 1 second. 1 second later, what's happening? Well, If you said we're still going to the right, you're correct. What about here? Okay, same thing, same thing, same thing, same thing. Okay, the whole way in the x direction, we're going at the same speed. We're just going to continue at the same speed. X, the velocity in the x direction is constant. We go at a steady speed. We're not accelerating at all in that direction. Now, that makes sense because gravity is acting straight. What is it? Okay, hopefully you said straight down. Because gravity is acting straight down, when we're going up in this first half of the motion, it's acting in the opposite direction. It's slowing it down. Then, when we get to a max velocity, at exactly the top, we are not going up, we're not going down. Our Vy is 0. As we go back down, we speed up as we go in the same direction of Vy. Pretty interesting. Right back. Okay, I'm back. Sorry for the interruption. Okay, so what's the takeaway that you need to know to complete today's assignment? The takeaway is this. As you're going up, you're slowing down because gravity is pulling you down. So it's fighting, the velocity is fighting against gravity is one way you could think about it until you come to a stop. At that point, the final velocity is 0. Then, as you come back down, you're speeding up in the y direction. A couple important things to note is the initial speed after you leave the ground is the same speed when you hit the ground, but the velocities are not exactly the same. Why is that? Well, even though the magnitudes are the same, we switch directions. Here, we were throwing or kicking the ball up. When we come back down, the final velocity will be the same, just in the opposite direction. Also, it's important to note that the time up will be the same as the time down. We'll talk more about the physics behind it, all of this, and some examples next time. But for today, that's the focus I want you to take away. So what's the takeaway? The takeaway is that when you kick something into the air or throw something into the air, the time up is the time down. The velocity is constantly changing as you change direction with that parabolic path. The time up is going to be the time down. And even though the velocity changes, if you kick something in the air at 10 meters per second, it's going to, at the end, come down with that same speed when it hits the ground. Hopefully that makes sense. I look forward to talking to all of you more about it when I come back and see you next Wednesday. Bye, everyone.